Today we're going to be looking at law of sine. So we started trigonometry before. We're going to continue working with trigonometry and the function of sine. So law of sine can be used to find side lengths and angle measurements of any triangle. If triangle ABC has length A, B, and C and represents the side lengths opposite the angles with measure A, B, and C, then sine capital A over little a equals sine capital B over little b equals sine capital C over little c. So let's take a look at an example and give this a shot. Best way to understand a theorem is to use an example. So we want to find the value of x. So x is right here. So x is going to be opposite C. We have A, angle A, and opposite angle A. So I'm going to set up sine A over A equals sine C over C. Now fill in the values that we have. So we have A, so let's put that in. So this is going to be sine 58 over, we have the value for little a, that's 9. Sine C we have is 35, so that's sine 35. But we don't have what little c is, so that's going to be x. Cross multiply this gives me x sine 58 equals 9 sine 35. Divide both sides by sine 58 to get x by itself. So I get x equals 9 sine 35 divided by sine 58. And that equals to about 6.1. So the value of x is now going to be 6.1. All right, let's take a look at number 2. So it says find the value of x to the nearest tenth. So when we look at this, we don't have g, but we have the number that's opposite it. We have the angle inside D, and we want to find what's opposite it. Well, I have 2 of the 3 angles, so I can use angle sum theorem to find measure of angle G. So measure of angle G equals 180 minus the 2 smaller angles added together, 60 plus 55. So this is just a variation on angle sum theorem. So this gives me 180 minus 115. When I subtract that, I end up with 65. So this is going to be 65. So now we have sine G over G equals sine D over D. So sine G is 65. We just solved for that. Over little g is 73. Sine D is sine 60. Over little d, that's going to be x. So cross multiply this. So this is going to give me x sine 65 equals 73 sine 60. Divide both sides by sine 65 to get x by itself. Divide by sine 65. So I get x equals 73 sine 65 divided by sine 60 divided by sine 65, which is going to give us about x equals about 69.8. So 69.8 is our value. And let's take a look at our next example. So we're surveying for a drone. What is the distance between the houses? So when we look at this, we have that this angle right here is 24. This angle is 106. So we're going to use across from that is 146.9. And then across from this is x. So we really don't need this length right here. It's just kind of an extra length. So let's go ahead and plug it in. So we have sine 106 over opposite 106 is the 146.9. So that's 146.9 equals, and then we're going to do sine 24, and then opposite that is x. So sine 24, opposite that is x. Cross multiply this out. This gives me x sine 106 equals 146.9 sine 24. Divide both sides by sine 106. Divide by sine 106. That gives us x equals 149 or 146.9 sine 24. Divide by sine 106. And when I type that in, I get that x equals about 62.2, and this is feet. So the distance between the two homes is 62.2 feet. So go ahead and take a look at the key concept here. So possible triangles in SSA cases. So consider a triangle in which A, B, and measure of angle A are given, and H is the altitude of the triangle. Shown below are the triangles that are possible when angle A is acute and when angle A is right or obtuse. Then we have a theorem that's connected to that as well, or a postulate that's connected to that as well. The sine of an obtuse angle is defined to be the sine of its supplement. So if measure of angle A is greater than 90 degrees and x equals sine A, then x equals sine 180 minus A. So this is what we've covered for today. Go ahead and write a summary of everything that we've reviewed, and then use these notes to help you answer the questions for today.